What if 5 million engines are failing right now? What if I told you that over 5 million engines from GM, Toyota, Honda, and Hyundai are failing right now? Some are catching fire with families inside. $70,000 trucks are dying at just 30,000 miles. There have been 42 fires, 12 injuries, and manufacturers are hiding the truth. Your engine could be next. Here's what they don't want you to know. The disaster by the numbers. Let me hit you with some numbers that should shake every car owner watching this. Pay attention, because your vehicle might be on this list. General Motors, 720,000 vehicles recalled for the 6.2-liter V8. But that's barely the beginning. Another 280,000 are now under federal investigation. GM has logged more than 28,000 complaints, and over 14,000 of those ended in complete engine failure, total loss of power. 12 injuries, 42 engine fires, not overheating, not smoke, actual fireballs under the hood while people were driving their Silverados, Tahoes, Yukons, and Escalades. Family vehicles gone. Toyota, the brand built on million-mile myths. They recalled 102,000 twin-turbo V6 engines in 2024, then quietly added another 127,000 in late 2025. We're talking brand-new Tundras, $90,000 Lexus LX600s, and Sequoias. Hybrids are still under investigation. Honda, 250,000 of their 3.5-liter V6 engines recalled for rod-bearing destruction. When those fail, metal shrapnel tears the engine apart at thousands of RPMs. Worse, NHTSA just opened a probe into 1.4 million Hondas dating back to 2016. Hyundai and Kia, 1.5 million engines recalled since 2017, and some replacement engines failed the exact same way. Added up, more than 5 million engines, nearly $8 billion in damages. This isn't a recall, this is an engine failure epidemic, and it's getting personal. So what's causing this nationwide engine nightmare? I dug into it, and the truth is absolutely explosive. In December 2025, Automotive News, a publication normally friendly to automakers, released a bombshell investigation. They spoke with university engine researchers, independent mechanics who've torn down hundreds of failed motors, and industry insiders who would only speak anonymously. What they uncovered is devastating. Modern engines are being pushed far beyond what they were ever designed to handle. Automakers are chasing record-breaking horsepower per liter, numbers once reserved for race cars. Engines now operate at temperatures that would have melted older power plants, with cylinder pressures once seen only on drag strips, all packed into engines half the size they used to be. Here's the scale. In the 1990s, a 6.0-liter V8 made 360 horsepower, 60 horsepower per liter. Today, Ford's 2.7-liter EcoBoost makes 325 horsepower, 120 horsepower per liter. The 3.5-liter EcoBoost Raptor, 128 horsepower per liter. That's double the power density. Same stress, half the metal to handle it. And it gets worse. To meet EPA and CAFE targets, manufacturers switched to ultra-thin oils. 5W30 and 10W40 became 0W20, then 0W16, and even 0W8, a fluid barely thicker than water. Thin oil saves maybe 0.5 miles per gallon, but it requires tolerances measured in microns, meaning machining, cleaning, and assembly must be perfect. Professor Greg Davis from the University of Michigan Flint puts it simply. Higher pressures create greater bearing loads and accelerated wear. Translation: automakers are demanding the impossible, and physics is finally fighting back. The invisible killer. There's an invisible killer silently destroying millions of modern engines, and almost no one outside the engine world knows it exists. It's called swarf. Dave from Dave's Auto Center, a master engine builder featured in the Automotive News investigation, explains it best. Swarf is microscopic metal debris left behind during machining. When manufacturers cut, drill, and hone engine blocks, large metal chips are easy to remove, but the ultra-fine particles from honing cylinder walls, those are deadly. Honing creates a slurry of metal dust, abrasive grit, and coolant. Dave calls it concrete. It's brittle, razor-sharp, harder than engine bearings, and it sticks to surfaces like glue. If even one microscopic piece gets between a bearing and a crankshaft, it acts like sandpaper at thousands of RPM. It embeds into the soft bearing, then grinds into the hardened crankshaft. Minutes later, scoring. Hours later, metal on metal. Days later, total engine failure. Dave's team spends hours cleaning each engine by hand. Hot tanks, pressure washing, compressed air, and scrubbing each passage 5 or 6 times. GM builds 1,000 engines a day per factory. Toyota, Ford, Stellantis, same story. Achieving hand-built perfection at that scale is impossible, so automakers rely on automated rinses and quick visual checks, hoping for the best. Powertrain tester Tom Howell sums it up. Thinner oils, tighter tolerances, and harder bearing materials are all contributing to the failures. Harder bearings mean less forgiveness, less debris absorption, and almost zero margin for error. It's a house of cards, and it's already collapsing. The perfect storm. Swarf and thin oil are only the beginning. What we're dealing with isn't a single design flaw, a single recall, or a single bad engine. It's a perfect mechanical storm, a pile-up of modern technologies and engineering compromises happening simultaneously. And when you stack them together, today's engines simply cannot survive long-term. Let's break down every factor that's killing modern powertrains. Start-stop technology. Every time your engine shuts off at a red light and restarts, oil pressure drops to zero for a brief but critical moment. With ultra-thin 0W20 or 0W16 oil, the remaining film protecting your bearings is extremely small. Cold starts cause the majority of engine wear, and now drivers are doing 40 to 50 start cycles in a single commute. Fleet trucks that rack up 150,000 highway miles in 2 years often outlast personal trucks with 50,000 city miles because they avoid this relentless start-stop abuse. Variable displacement oil pumps. Old engines used fixed pumps, simple, predictable, reliable. New engines rely on computer-controlled pumps that constantly adjust pressure. If the pump lags after a start-stop cycle, miscalculates temperature, or malfunctions, your bearings get starved of oil. More complexity equals more failure points. Extreme turbocharging. Turbocharged engines run 2,000 plus psi cylinder pressures, double what naturally aspirated engines see. Turbos spin at 150,000 to 200,000 RPM and depend entirely on clean, properly weighted oil. Any contamination or delayed pressure destroys turbo bearings, sending metal shrapnel throughout your engine. One turbo failure can kill the entire powertrain within seconds. Direct injection. DI systems spray fuel at 2,000 to 3,000 psi directly into the chamber. Great for efficiency, terrible for longevity. Higher combustion pressures, more stress. No fuel washing the valves means carbon buildup. Hotter temperatures mean thinner oil film. Everything gets pushed harder. COVID-era manufacturing. Engines built from 2020 to 2022 came from chaotic factories. New suppliers with no track record, absent quality inspectors, skeleton crews. GM struggled with out-of-spec rods. Toyota admitted contamination issues. Stellantis even found sand trapped in engine blocks. These engines are now hitting 60,000 to 100,000 miles, where hidden defects finally surface. Cylinder deactivation. Turning V8s into V4s sounds efficient, but it creates uneven temperatures, uneven block expansion, and shock loads when cylinders reactivate under load. Stack all of this together, and you get one unavoidable truth. Modern engines aren't failing from one problem. They're failing from 10 problems happening at the same time, and no engine can survive that forever. If you're finding this information helpful, please hit that like button and subscribe to support this channel. The conspiracy. Here's where things get really suspicious. Because this is the part manufacturers don't want the public to see. Independent engine builder Eric Berg spent 3 years trying to obtain a failed Toyota twin-turbo V6. Toyota aggressively bought back every blown engine as a core exchange, keeping them out of independent shops and off YouTube. He finally got one, and the teardown was explosive. The main bearings, the ones supporting the crankshaft, were destroyed, shredded, scored, and heat-burned. Total failure. But the rod bearings, fed by the same oil circuit, were perfect, pristine, no wear at all. If debris or contamination were the cause, both should be damaged. They share the same passages and the same oil. Only the mains failing means one thing. This is a design flaw. Maybe the oil passages are too small. Maybe the clearances are too tight. Maybe the bearing material can't handle the load. But design flaws are far more expensive to admit than manufacturing debris. Just look at Hyundai's Theta disaster. They blamed debris, recalled 1.5 million engines, replaced them, and the replacements failed the same way. That's not dirt. That's design. And here's the smoking gun. GM's fix for its 6.2-liter recall is switching from 0W20 to 0W40, twice as thick. If thin oil wasn't the problem, why is thicker oil the solution? Because manufacturers know tolerances are too tight, and thin oil can't protect these high-pressure engines. But admitting that means lawsuits, billions in costs, and regulatory backlash. So they blame debris, but the engines tell the truth. The real villain. So who's really behind this engine disaster? The answer is bigger than any automaker. CAFE standards, corporate average fuel economy regulations. CAFE rules set the average miles per gallon every manufacturer's entire fleet must reach. And the targets have become aggressively unrealistic. From 2024 to 2026, fuel economy requirements rise 8% per year, then 10% in 2026, ending with a mandated fleet average of 49 miles per gallon. Meanwhile, your F-150 gets around 20 mpg. Your Tahoe sits near 18, your Corvette around 16. There is no mathematical way to hit a 49 mpg average using traditional engines. And the penalties are brutal. $17 per vehicle for every 0.1 mpg a company falls short. If a manufacturer sells 2 million vehicles and misses the target by just 1 mpg, that's 10 times $17 times 2 million equals $340 million in fines for 1 mile per gallon. So companies squeeze out every fraction of mpg they can. Tiny turbo engines, thin oil, microscopic tolerances, start-stop, cylinder deactivation, anything to avoid fines. Engineers didn't forget how to build reliable motors. What changed is the regulatory pressure pushing designs past what's reliable at mass production scale. Automakers have done the math. A predictable rate of failures is cheaper than missing CAFE. Your engine's lifespan versus their compliance. And they chose compliance. It's getting worse. Here's the part that's going to make you furious. This crisis isn't stabilizing. It's about to get worse. Yes, the Trump administration rolled back some CAFE standards in 2025. You'd think that would relieve pressure on automakers and help reliability. Wrong. What actually happened is far worse. EVs were removed from fleet average calculations. Before this change, manufacturers could count EVs at 200 to 300 mpg equivalent. Those ultra-high numbers offset their gas guzzlers. Ford could sell 15 mpg F-150s, 17 mpg Expeditions, 16 mpg Mustangs, and EVs like the Mach-E and Lightning would balance it all out. They could even buy credits from Tesla. Not anymore. EVs no longer count, but the fuel economy requirement still exists. Rolled back slightly to 34 mpg by 2031, but now automakers must hit that number without EVs to offset trucks. And that means one of 3 things is coming for your truck. Option 1. Even smaller engines, thinner oil, tighter tolerances, pushing the limits further. More failures, more recalls, more engine disasters. Option 2. Huge power cuts. Your next F-150 may drop from 400 horsepower to 250. Your Silverado might tow 5,000 pounds instead of 13,000. Option 3. Universal hybrids. Every truck, every SUV, every model gets a battery and electric motor. More components, higher prices, more things to break, and battery degradation tanking resale value. And here's the kicker. Automakers aren't walking away from EVs. They've spent billions building these platforms. And as political shifts in 2028 tighten standards again, they need to be ready. So they'll keep using the same strategies that caused this mess, despite the proof staring them in the face. 5+ million failed engines, $8 billion in damage. Hyundai alone facing $5 billion for 3.3 million engines, and nothing is truly changing. What this means for real people. This isn't just about recalls and statistics. This is about your money, your safety, your family. These failures are happening on vehicles that cost as much as a house. A Silverado High Country, $80,000. A Tundra TRD Pro, $75,000. A Lexus LX600, $100,000 plus. A loaded Escalade, $120,000. And engines are dying at 30,000 to 40,000 miles, sometimes even less. Just last night, a Tundra owner posted another main bearing failure at 35,000 miles on an 18-month-old truck. Complete engine replacement. Imagine this. You save for years. You finally buy your dream truck for $70,000. Payments, $1,200 a month. 6 months later, driving your kids to school, you hear knocking, then grinding, then the engine seizes. You coast to the shoulder, terrified. The dealer confirms it, full engine replacement. It's under warranty, but replacements are on a 2-month back order. You're still making $1,200 payments on a truck sitting dead in a service bay. And when you finally get it back, you now own a practically new truck with a replaced engine. Resale value destroyed. Who buys a 3-year-old truck that blew its engine at 30,000 miles? Some owners try lemon laws, but many states exempt vehicles under recall. Manufacturers say, "We're fixing it," and you're stuck. And remember, Hyundai's replacement engines failed the exact same way because the design itself was flawed. Now let's talk safety. GM logged 14,000 complaints involving complete loss of propulsion, engines dying mid-drive, 12 injuries, 42 fires, 42 engines caught fire while people were driving their families. Toyota reports stalling and loss of power. Honda's failures involve connecting rod bearings, meaning metal fragments tearing through your engine at thousands of RPM. A rod can punch through the block or the hood. Hyundai's Palisade recall warns that a broken valve spring can blow a hole straight through the engine. These aren't minor issues. These are life-threatening mechanical failures happening in vehicles you trusted with your family's safety. Steps to protect yourself. This engine crisis is real, but you can protect yourself. Here's a practical, step-by-step action plan to dramatically reduce your risk. Step 1. Check your VIN now. Go to nhtsa.gov and use the Recall Lookup tool. Enter your VIN and see if your vehicle is part of a recall or investigation. If it is, schedule the repair immediately. These failures often happen without warning. Fine one day, destroyed the next. Step 2. Cut your oil intervals in half. Ignore the 7,500 to 10,000 mile intervals. Do 5,000 miles max, or 3,500 if your manual says 7,500. An extra $50 to $75 a year in oil changes is nothing compared to a $15,000 engine replacement or a $70,000 truck becoming worthless. Use high-quality oil, Mobil 1, Pennzoil Platinum, Valvoline, Castrol, and the correct spec, Dexos 1 Gen 3, etc. Step 3. Disable Start-Stop. If your vehicle has a button, press it every time you drive. Some cars reset the setting. If yours does, a $50 to $100 OBD2 device can disable it permanently. You may lose 0.2 mpg, but you avoid dozens of unnecessary wear events every day. Step 4. Consider slightly thicker oil, after warranty. Once out of warranty, a small step thicker can help. Example, if your Subaru runs 0W16, but Japan allows 0W20 and 5W30, run 0W20. If GM is now using 0W40 for the 6.2L recall, consider 5W30 after warranty. Don't go extreme, just one grade heavier. Step 5. Monitor your engine. Listen for new ticking, knocking, or rattling. Check oil every 1,000 miles. Watch oil pressure. Low warm idle pressure is a red flag. Step 6. Be smart when buying. Avoid first-year redesigns. Avoid 2021-2024 model years altogether if buying used. A proven 2015-2019 naturally aspirated V8 with 100,000 miles may be safer than a 2023 turbo with 30,000 miles. Step 7. Consider an extended warranty. For 2020-2024 used vehicles, a $2,000 comprehensive warranty covering engine internals may save you from a $15,000 to $20,000 engine replacement. Read the fine print. Make sure it covers bearing failures. Follow these steps and you'll massively increase your engine's chances of surviving this industry-wide crisis.